reason hit by 9
Yeah, he took the South and Obama took...
I don't know, I saw it 64 to 56 before I left for Obama. That was like an hour ago.
For what state?
No, that was overall. That was electoral vote, 64 to 56.
So, what we're going to do for this one in particular... We're here, right? Nothing too crazy.
Professor Ryan?
Yes.
So you put it right, like when you put the let u equals sign, you can't make it sign of t.
No, it's got to be this one.
Oh, okay.
Yeah, because this is the problem area, because it's not matching here. All right. Ahead. Any questions I can answer here? Let's try one more.
Oh no, sorry.
E to the 3x. And again, I want you to find G prime of x. This isn't anyone's notebook? It was left here last class? It's here? G.
Yeah, it's e to the 3x.
It's going step by step.
That's probably the reason I have this, is I can actually see what he's writing. Because I can't see. You and I can't see. We're blind as bad.
Maybe we're saying that
I can see it. It's magnified, so I can see everything.
But no, but talk about the actual electoral vote.
That's why I put it on YouTube for you fools.
He's up by like 10.
Blind ass shit. Who cares my video?
Because that was all the sound.
Let u equal e to the 3x.
Was Maria one of the past British students, or
She was like a staff there.
My eyes are so dry. It's killing me.
All I did was I took the derivative of whatever on top, that was here, and then I just plug in whatever's on top.
there was like 4 or 5 people on the thing.
That's what I did for the
Yeah,
last
Obama's
two.
down by
Figure
11.
out which one was
So I got something like this.
March school.
How are we doing with all this?
Oh, okay.
Yeah, it's the same thing.
Part 2 is actually the more interesting part. To me.
So the second part's just the derivative of e to the 3x, right? Yeah, it's not super intangible. side are you? What side were you using to get those stats?
It's gonna be like a
So this is where the antiderivative is going to come into play.
.com /
Okay.
Okay.
That was all part one.
Now we did this problem the long way the other day.
That was fun.
We found out that the answer was actually 1/3. And today we'll see why. First of all, f of x in this case is x squared, right? It's the function of interest, x squared. Capital F is the antiderivative. What is the antiderivative of x squared?
1/3 x to the third.
1/3 x to the third power, right? Here's some new notation for you. You'll see me do this from time to time. So the way the theorem works is it says we're going to take the antiderivative and evaluate it minus the antiderivative and evaluate it. That's what this is saying. What happens here? 0 is gone. And what's 1 to any power, actually? 1/3. It's always 1. And we proved that doing it the long way last time, right? But this is a whole lot easier. Like, way, way, way easier. We are going to need the antiderivative.
Cos pi over 2 is a -1, right?
What's the antiderivative of cosine of x?
Cosine.
Positive sine x, right?
Cosine of pi over 2.
There we go. I knew it. I was forgetting if it was a second or a third point. It's the second point, right? Pi is the third point.
Remember the whole plus c thing?
Stupid.
The whole plus c thing is going to cancel because when you subtract, the c's cancel. So we don't have to worry about that plus c for now. When we get to the indefinite, it's going to
It's 1.
What's sine of pi over 2?
1.
1. What's sine of 0?
0.
Now what does this say? Physically what this means is if you take a cosine curve, right, continuous, right? I'm seeing that the area here is exactly equal to what? Exactly equal to 1. I want you to think about that. Sine wave has irrational numbers all over it, right? Sine of 15 radians is like some crazy number. But the area from 0 to pi over 2, another irrational number, is exactly 1. That should mess with your head a little bit.
It does.
You okay?
No.
Actually, physically, you would say it's 1 square whatever, as far as area goes. But remember, integral is much more than just area under a curve.
is whatever the units.
Whatever's the unit. So square, meters, whatever.
You said it's more than just the area under the curve. What else is it?
Well, we're not to that point yet, but there's, when you get to physics, you'll see.
Okay.
Yeah, physics for sure, there's a ton of applications. In fact, almost every formula and everything that you use is derived from an integral of some sort, or differentiation. Alright, so we're just going to just do integral after integral after integral. Okay? These are called definite integrals because they have boundaries. Eventually we'll get to what if there are no boundaries, and we just want to know what is the function left over after we take the integral. That's when we get the plus c in. Alright. We don't have that yet, so we will do that there. So we're going to need the antiderivative of e to the 2x. Let's just say that have been evaluated at the boundary state. Now this author will probably do something like this. Don't know why. Sometimes he does, sometimes he doesn't. And your solution manual is all over the place. But either way is fine for me. Sometimes finding the antiderivative, you have to get a little creative. So what could I do? What's an option here? Make this a little easier. Yeah.
Can you separate
You
it?
can separate it. That's exactly right. We're going to take a minute so you can find the antiderivative and then evaluate it at the boundary points. No. The definite integrals, you don't need. The c's cancel. Because you're subtracting. When you get indefinite.
You lost my boss.
Thanks,
No, it does. So she puts the formula in.